A new method that we're learning on lesson 63, and that is elimination. If we look at here, we have learned to solve a system of equations by substitution. Now, in order to do substitution, you have to get one variable by itself. Now, if you look at this, that's going to be difficult to do, so sometimes it's better to do elimination. Now, elimination can also be called the addition method, and I'll show you why. If we have equations, we know here that 5x plus 2y is equal to 9. We know that is equal to 7. So if 9 equals 9, we know that left side has to be equal to 9. And we have this, we know that left side has to equal 7. So 7 equals 7. If you take the two equations and you add them together, you get 16 equals 16. So we see if we add the two system of equations, we still get a true statement. Okay, when you add them, it still would be true, since the left side is equal to 9 and the left side is equal to 7. All right, so let's go ahead and do that. So we add these two equations here. Okay, 5x plus the negative 5x. If you add opposites, we know that's just equal to 0. Okay, 2y plus 6y is 8y. And then when we add 9 and 7, we get 16. Divide by 8 to get y is equal to 2. Oops. All right, so once we add those, the method becomes the same as we did for substitution. Once you have y, you can substitute 2 into either one of those equations then to get x. So we'll substitute that back into the first equation. We know y is 2, so we substitute that. Anytime we substitute, we'll put in parentheses. Okay, 2 times 2 is 4. So subtract 4 from both sides, we get 5 is equal to 5x. So that x is equal to 1. So the ordered pair, the coordinate that would work for both equations would be the coordinate 1, 2. Okay. Now it says check 1, 2 for x and y in both original equations. I put that. What we can do is we can go back in there and we can put 1 and 2 back in to double check to make sure this is correct. If we look at this, we already put the 2 in. If we put 1 in, we get 5 plus 4, which does equal 9. All right, let's substitute that in the second equation. If we put 1, substitute that in for x, we would get negative 5. Substitute the 2 in for the y, we would get 6 times 2 is 12. And then we see this also to be true. Negative 5 plus 12 is 7. You don't have to check. I probably won't check when we do the next example, but you always have it available to put it back in to make sure that's true. All right, solve the system by elimination. Now, we could also, just like the other equation, we could also use subtraction and subtract the two equations. We see they're the same sign. So in the case to eliminate the y, we would need to subtract the 2. So we have here, and just to illustrate this, we know the top that both sides are equal to negative 5. We know the bottom that both have to be equal to 5. Show this if we were to subtract both, change the sign of that, we get negative 10 is equal to negative 10. So subtracting still enables us to have the same value. All right, so let's go ahead and do that. Okay, subtract each one, so we have 7x minus 2x would be 5x. 3y minus 3y is 0. It would go away, so 5x plus is 0. All right, and then negative 5 minus 5. You want to make sure that you're subtracting each one. It's easy as we get over here to forget those, so we get negative 10. All right, you take off that 0. Divide by 5. So we have negative 10 divided by 5 gives me x is equal to negative 2. All right, then just like we did before, we're going to substitute that negative 2 back into one of my equations. I'm going to do the second equation now, keeping it as the original equation after we altered it. All right, so we get negative 4 plus 3y is equal to 5. Add 4 to both sides, get 3y is equal to 9. Divide by 3 to get y equals 3. So the answer solution, that the coordinate that would, the ordered pair that would be a solution to both these, or where the two lines intersect, would be -2, 3. All right, now we look at this one. We may also use multiplication. I won't show this, but just like we saw if we add the two equations and subtract them, if we multiply both sides of the equation, it still makes it equal. If you have 5 equals 5, and you multiply both sides by 2, you still get 10 is equal to 10. You still get a true statement. All right, now what we're going to do first is put this in standard form. The standard form is where you write x and y on one side and your number on the other. So in order to do that, I'm going to subtract 8x to get that x on the left side. So we have -8x plus 5y is equal to -2. All right, this one's already in standard form. You've got 4x minus 3y is equal to -2. So we look at this, okay, we look, well, we've got -8x and 4x. Could I multiply one of those by something so that they're opposite? So when I add them, they go away. We look at this 4x. If I multiply it by 2, we would get 8x. So now if I multiply it by 2, I have to do the whole equation, multiply the whole equation by 2. All right, so we'll do that. Okay. All right, we distribute that 2. We get over here, a little bit. Okay, we would get -8x. Okay, didn't do anything different with this equation. We multiply this equation by 2. We get 8x minus 6y is equal to -2. Okay, add these, we get -1y is equal to -4. Okay, opposite, we divide by -1. We divide by -1 on both sides. We get y is equal to +4. Okay, we're going to go ahead then and substitute that back into one of our equations to get x. We'll substitute that in the first one. We get 5 times 4 is equal to 8x minus 2. All right, we get 20 on the left side. All right, this does not look like it goes in evenly. Okay, all right, we'll keep going with it. If there's an error, we'll talk about it tomorrow. We do this here, we add 2 to both sides. We get 22 is equal to 8x. Divide by 8. And then we reduce that. All right, we'll look at that tomorrow. Somewhere I think I made an error, but we'll see here. Oh, I think I found it. All right, back here, this is a good point. When we took 2 times a -2, I didn't multiply that over here. Okay, and that's easy to do. We go too fast. So, all right. Go back here, we would get, we multiply 2 by -2, we get -4. And then when we add those, we get -6. Divide by -1, we get y equals 6. All right, this should work out better now. Okay, so if we put, now, yes, this will work. Okay, now if we substitute that 6 in, 5 times 6 is 30. All right, now it works out. 30, we add the 2 to the other side. We get 32 is equal to 8x. Divide by 8 to get x is equal to 4. All right, example number 4. Still multiplying 2 equations. Now this one, okay, instead of just multiplying one, we're going to have to multiply both. All right, we look at this. We've got -3y and 5y. So this is where we take the process of the least common multiple. 3 and 5, or when we found common denominator, what is the least common multiple? And it'd be 15. So I want to multiply this by something to get -15. So when we do that, we're going to take this equation. Okay, we're going to multiply it by 5, so I get that -15 there. We're going to take this whole equation, we're going to multiply everything by 3. All right, we do that, we get 20x